So now I'm going to show you how you can get other gas laws from the combined gas law. Now they all have names, Boyle's, Charles, Gay-Lussac's, but I don't really care about their names too much because they don't really help us understand. We'll go over them in class, but you don't have to memorize their names because it's not super duper important. All right, so this is our combined gas law. P1 V1 over T1 equals P2 V2 over T2. But what if not all of the variables are changing? So for example, what if the volume is staying the same and only the pressure and temperature are changing? That can happen, right? Like if I have a rigid container that can't expand and contract. Okay, so if the volume's the same on both sides, then I could just cancel it out, right? So I would get an equation that just relates pressure to temperature, okay? Similarly, what if only the volume and temperature were changing? Like we talked about the balloon getting smaller in a cold garage or expanding when you heat it up. So if pressure stays constant, I could cancel out the pressure and I would get V1 over T1 equals V2 over T2. Okay. And finally, if temperature is staying constant, you probably see where this is going already, I could cross out the temperature and I would get P1 V1 equals P2 V2. Okay, so what's nice about this is that you really don't need to memorize these gas laws, okay? I don't think that's a great use of your time. If you know the combined gas law, you can just cancel anything out that stays constant. So let me show you what a problem with this would look like. All right, so this problem says a sample of gas has a pressure of 3 atmospheres at a temperature of 200 Kelvin. What will its pressure be at 400 Kelvin? Sorry, it's not super clear. Let's just say 400. Now, initially, when we start with this equation, we see we have 2 different temperatures and 1 pressure. Now volume isn't mentioned at all. So since volume isn't mentioned at all, we can just assume volume stays constant. So my new equation would be P1 over T1 equals P2 over T2. So now I'm gonna list my variables off to the side. All right, so I know that initially the pressure is 3 atmospheres and its temperature is 200 Kelvin. And I wanna find the pressure at 400 Kelvin. So I can substitute in 3 atmospheres over 200 Kelvin equals P2 over 400 Kelvin. And then I can cross multiply. So 3 times 400 is 1200 equals 200 times P2. And I divide both sides by 200 and I get that P2 equals 600. Oh, sorry, 6. Not 600. That would be really, really high pressure. 6 atmospheres, which makes sense, right? Because we learned that as temperature increases, the molecules move faster and have more collisions, so pressure should increase as well. So at the higher temperature, when we double the temperature, we double the pressure as well.